Let's take a look at the 2018 Leaving Cert Higher Level Paper 1 Question 4. This particular question is a question on complex numbers, some proof by induction, and a bit of de Moivre's theorem. Right, let's have a look at the question. 4, part A. Prove, using induction, that if n is a positive integer, then cos theta plus I sine theta to the power of n equals cos n theta plus I sine n theta, where I squared is minus 1. So we're basically trying to prove de Moivre's theorem using induction. Right, so let's get started. So our first step, the p of 1, so where n equals 1. So you fill a 1 in for n. So cos theta plus I sine theta to the power of 1 is equals to the cos of 1 times theta plus I sine of 1 times theta. So that's clearly true. So that's just basically telling us cos theta plus I sine theta equals cos theta plus I sine theta. So that's fairly straightforward. We can say, therefore, true for n equals 1. So true for n equals 1. Right, moving along. So the p of k. So that's where we assume it's true for n equals k. So we're assuming that the following is true. That cos theta plus I sine theta to the power of k is equals to cos k theta plus I sine k theta. So we're assuming this is true, and then we have to prove that it's true for n equals k plus 1. So the p of k plus 1, we have to prove that it's true for n equals k plus 1. So we're trying to prove, basically we are trying to prove that the cos theta plus I sine theta to the power of k plus 1 is equals to cos of k plus 1 times theta plus I sine k plus 1 times theta. That's what we're trying to prove. Okay. So as usual for induction, we start off with the left-hand side. So starting this proof, right, we've got cos theta plus I sine theta to the power of k plus 1. Well, that will equal, what will that equal? That will equal cos theta plus I sine theta to the power of k times cos theta plus I sine theta to the power of 1. So now what we can do is we can understand that we can use this, our assumption. So our assumption tells us that cos theta plus I sine theta to the power of k equals cos k theta plus I sine k theta. So I'm going to replace this cos theta plus I sine theta to the power of k with cos k theta plus I sine k theta. So equals cos k theta plus I sine k theta times, so this times cos theta plus I sine theta. So then what happens next is we just got to multiply it out, just bracket by bracket. So cos k theta by cos theta, you just call that cos k theta cos theta. Then you've got cos k theta by I sine theta, so that would be plus I times cos k theta sine theta. Then you've got I sine k theta by cos theta, so that would be plus I times sine k theta cos theta. Then you've got I sine k theta by I sine theta, so plus I squared sine k theta sine theta. So all I've done there is just multiply out the two brackets. Now let's collect the reals and collect the imaginary. So this is a real term, this is an imaginary term because it has an I in it. This is an imaginary term because it has an I in it. And I squared is minus 1, so this is a real term. So remember that I squared is minus 1. So grouping the real terms first, the reals I've got cos k theta cos theta. And then I squared, remember, is minus 1, so therefore minus sine k theta sine theta. Alright, so that was sine k theta. Then, they're the reals, then grouping the imaginaries, plus I times, then we've got cos k theta sine theta plus sine k theta cos theta. Right, now the next step, we will use our trigonometric formulas, looking at the compound angle formulas in particular, because what we have here will fit the compound angle formulas. So these are the compound angle formulas that I'm talking about. So let's examine our terms. If we look at the first half here, the reals, you've got cos theta minus sine k theta sine theta. So cos minus sine. That, as you can see, fits the third of the compound angle formulas, cos minus sine. Therefore, this can be rewritten. All right, so I can say equals, so that's like the cos of A plus B, where A, in this case, is our k theta, and B is our theta. So the next line, I can call this cos of k theta plus theta. Right, then we look at the imaginary part. So looking at the imaginary part, we've got cos sine plus sine cos. Cos sine plus sine cos, right? So that fits the first of the four formulas, the one you see here. So you've got your sine cos, that's the same as cos sine plus cos sine. So we have a sine A plus B situation here, where A is your theta, your k theta, and B is your theta. So I can write that as plus I times sine A plus B, sine k theta plus theta. Right, that was the important part, and the rest of it's going to be straightforward. So that's going to be the cos of, factorize out your theta, and in the bracket you'd have k plus 1 plus I sine, factorize out your theta, and in the bracket you'd have k plus 1. So therefore we can call that equals to cos of k plus 1 theta plus I sine k plus 1 theta. And that's exactly what we were trying to prove. Right? So therefore that is the proof done. True for n equals k plus 1. Now in the exam you should probably finish this by giving your usual induction speech. I assumed it was true for I showed it was true for n equals 1, assumed it was true for n equals k, proved it was true for n equals k plus 1. Therefore, by induction, it's true for all values of n. Part B, hence or otherwise, find minus a half plus root 3 over 2i in its simplest form. So let's convert that to polar form first. Quick sketch. Minus a half plus root 3 over 2i. So there would be the complex number there. Minus a half plus root 3 over 2i. Alright, let's get it in polar form. So the two things we need the modulus, which is that distance there, and then we need the angle, which is that angle there. So let's get the modulus first of all. R is equal to the square root of a squared plus b squared minus a half squared plus root 3 over 2 squared, which will equal 1. And then we have to get the angle theta. Now, before we get the angle theta, I think it's easier to get the angle A and then take it away from 180 to get theta. So A, well, to get the angle A, that distance is a half and that distance is root 3 over 2. So we can say that tan of the angle A is equals to the opposite over adjacent, root 3 over 2, all over a half, which is basically equals to root 3. So then A equals tan inverse root 3. So A is equal to 60 degrees. Therefore theta, which is the angle starting from the positive x-axis or the positive real axis, is 180. Take 60, 120 degrees. And maybe we should get it in radians. Theta is 2 pi over 3 radians. It doesn't really make a difference whether you use radians or degrees in this question. I'm going to use radians. So therefore, we have just figured out that minus a half plus root 3 over 2i can be written in polar form as 1 bracket cos 2 pi over 3 plus I sine 2 pi over 3. Right, now I need to put this to the power of 3 using the Myers theorem. So minus a half plus root 3 over 2i to the power 3. So the Myers theorem tells you put the modulus to the power and you multiply the angle by the power. So I've put the modulus to the power and multiply the angle by the power. So continuing on here, so that's going to be 1 bracket cos, so 3 by 2 pi over 3 is just 2 pi plus I sine 2 pi. So now to convert that back to rectangular form, that's going to be 1 bracket, so the cos of 2 pi is 1 plus I times, and the sine of 2 pi is 0. So that's just going to be 1 plus 0 I.